Okay, morning boys. We are going to be looking at surds, but more specifically rationalising the denominator, which is the last thing to cover with surds really. So rationalising, we're going to look at the word rational first, because I haven't really explained what that is before. So there are two types of numbers we'll look at, rational and irrational. Rational numbers are numbers like 2, 7, a third, 2 ninths, or minus 11 thirtieths. These are all numbers that can be written as fractions. Irrational numbers are surds, essentially, like root 2, 2 root 3, root 7, or 8 root 31. You can also have surds like root 2 minus root 3. That's also an irrational number. Okay, so to rationalise the denominator, well, you hopefully know what a denominator is. The denominator in a fraction is the number at the bottom. So what we're really going to be doing is looking to turn the denominator into a whole number. Okay, we're not going to be turning it into a fraction, we're turning the denominator into a whole number, a rational number. Okay, so let's look at an example. Rationalise the denominator for 3 root 6. So root 6 is the denominator and it's irrational, and we somehow need to turn that into a rational number. So what we're going to do is this sort of little trick. We're going to times the top and the bottom by root 6. Okay? Because if we times by root 6 over root 6, notice how, if you think about root 6 over root 6, they would just cancel out. So really we're just timesing it by 1, which isn't doing anything. Okay, so times the top by root 6 and you get 3 root 6. Times the bottom by root 6, and root 6 times root 6, we've done this in class before, is just 6. So the denominator is now a whole number. We've reached our target. We're just going to simplify the fraction. So the 3 and the 6, they have a common factor of 3, leaving us with root 6 over 2. So we simplified the fraction now, and that will be the final answer. Okay, we've turned the denominator, as you can see, into a whole number, and we've rationalised the denominator. Before, the denominator was root 6, and now it's 2. Let's have a look at another example now. So 5 root 8. I'll show you two methods to do this question. The first method would be to do the same as shown above, so times the top and bottom by root 8. Okay? If you times the top by root 8, you get 5 root 8, times the bottom by root 8, and root 8 times by root 8 is 8. Okay, but now we have to simplify root 8 as well. So 5 root 8, well root 8 was the biggest square number that divides 8, and that's 4, so we can write it as root 4 times root 2. Okay, now we change root 4 for 2. We can change this fraction to 10 root 2 on the numerator and 8 as the denominator. Now 10 and 8 have a common factor of 2, so when we divide by that common factor, we get 5 root 2 over 4. Okay, good stuff. Right, we'll look at one more. Well, we'll look at the same example actually, but done in a different way. So instead of timesing by root 8 over root 8, we could simplify the surd first. So 5 root 8 could be simplified. Root 8 can be written as root 4 times root 2, because 4 is the biggest square number that divides 8. Changing that becomes 5 times by 2 root 2. 5 over 2 root 2, sorry. Now to rationalise this denominator, we don't have to times by 2 root 2. We can just times the top and bottom by root 2. If we times the top by root 2, we get 5 root 2. If we times the denominator by root 2, we get 2 times 2, because root 2 times root 2 is 2. This ends up being 5 root 2 over 4. Okay? So there are some simple examples of how to rationalise the denominator. I would recommend simplifying the surds first, because that can sometimes make the question far easier. Okay, here are some examples for you to try yourself. Now I'm not going to give you the solution now, I'll give you the solution on Friday's lesson. Okay? So do those questions please. Right, so almost 5 minutes in, we're going to look at some more difficult stuff now. Still rationalising the denominator, but the denominator now is not so simple. Okay? It's made up of 2 surds in this case. And now there's a new way to rationalise this denominator. we need to turn the denominator, remember, into a whole number. And what we will do is we multiply the fraction, top and bottom, by the conjugate of the denominator. The conjugate of the denominator is you just take the second surd, in this case, and you change the sign. So we say we're going to times it by root 2 plus root 7. Okay. This root 2 plus root 7 is the conjugate of root 2 minus root 7. This will hopefully become clear once we start getting into the question. Okay. So I'm going to rewrite the top as, well, 1 times root 2 plus root 7 is root 2 plus root 7. And I'm just going to rewrite the bottom in 2 brackets. Okay. And now there's space for you to try this part yourself, so I want you to expand these 2 brackets yourself. Okay? Try that yourself, and then check if it's right. So, you should have done something like this. You might have done the crab claw method or whatever else you've been taught before. Okay? So, changing it to something like that, we get root 2 times root 2 is 2. Root 2 times root 7 is root 14, or root 2 times root 7. Then take away root 7 times root 2, and root 7 times negative root 7 is negative 7. Okay? Notice how the 2 root 7's cancel. And then we're just left with 2 take away 7 is negative 5. Okay, so I've sorted out the denominator now. I'll rewrite the numerator, and the denominator from the expansion, from the working at the top there, is just negative 5. So I've turned the denominator into a whole number, which was the aim. Okay, so timesing by the conjugate is the little trick. Here's a new question, slightly more complicated, even further. So we're going to do the same thing. We're going to times the top and bottom by the conjugate of the denominator. Okay, so that's the conjugate from the first question. What is the conjugate of this going to be? Try and write it down yourself now. So you should have written, you just change the sign of the second surd. So it's root 5, take away 2 root 3. That's the conjugate. Very easy. Okay, so I'm going to rewrite this in brackets. So we need to do some working. We need to work out what the top will be and what the bottom will be. So do some working now. Try and see if you can expand these. Pause it really and then do it yourself. And I'll go through it quickly. Rewriting it like this. You get root 3 times root 5 is root 15. Root 3 times negative 2 root 3, well, it becomes negative 2 times 3, which is negative 6. 2 times root 5 is 2 root 5. 2 times negative 2 root 3 is negative 4 root 3. Okay, I can't simplify that any further. There are no like surds. Right. Now, timesing the 5 plus 2 root 3 by its conjugate. Expanding in the usual way. Anyway, expand the first bracket. Root 5 times root 5 is 5. Root 5 times negative 2 root 3 is negative 2 root 15. And then we've got this plus 2 root 3 times root 5, which is 2 root 15. And 2 root 3 times negative 2 root 3. Well, that becomes 4 root 9. Carrying on. The 2 root 15's cancel. We've left with 5, take away 12, because it's 4 times 3, because root 9 is 3. And 5 take away 12 is negative 7. Okay, so now I have expressions for the denominator, which is negative 7, and the numerator, which is this root 15 minus 6 plus 2 root 5 minus 4 root 3. Okay, good stuff. Just one point to notice before we stop. I could rewrite the first equation. Instead of putting the negative here, I could put the negative at the top there. With this second equation, please never try this. You cannot cancel the root 3's. That doesn't work. Okay, you're not allowed to do that. Okay, and you can't cancel the 2's for the same reason. You just don't try it. Follow this sort of routine, times by its conjugate, and rationalise the denominator. in that way. Okay? Thanks for watching. See you on Friday.